Hello everyone, in this video I'll talk about the differences between 8051 PIC and ARM architectures. So 8051 is a CISC architecture processor, while ARM and PIC are RISC architecture processors. CISC architecture processors are optimized for low code density, and hence the instruction set architecture that these processors provide have instructions for very high level operations. And this makes the design of these processors complex. They tend to occupy more space and consume more power. On the other hand, RISC processors have an instruction set architecture with instructions which are fundamental and simpler. And because of the simplicity of the individual instructions that a RISC ISA provides, the design of these CPUs is simple as well, and this makes RISC processors small in size, and hence they consume less power as well, because the number of transistors is less. Now on the basis of machine models, we can also differentiate these architectures on the basis of the machine models on which they are based. PIC and 8051 use a mix of accumulator register and a register memory machine model, while ARM uses a strict register resistor machine model. Now I'll tell you about the different machine models that a processor can have. So based on where the operands come from and where the result of an operation is sent to, we can classify processors into 4 categories. The first is a stack-based machine model. In a stack-based machine model, we maintain a stack of values, and for every operation that the ALU does, for every operation that the ALU performs, the arguments are taken from the top of the stack and the result is pushed onto the stack. This kind of machine model is the easiest to implement, and you will be surprised to know that the Java virtual machine, the one that executes all of your Java programs once they are compiled to bytecode, uses this kind of machine model. And the other machine model is an accumulator based machine model, wherein one of the operands is surely going to be the accumulator, while the other operand can come from memory, and the result of the operation will also be stored in the accumulator itself. And the register memory model is more flexible than the accumulator model, in the sense that you can have more than one registers, and the result of the operation may be stored in a register other than the accumulator, and you can have operands coming from the memory as well. In the register model, the operands will strictly be available in the registers. So you will have to have explicit load operations for fetching operands from memory. So if you have operands in memory, you will have to have instructions that fetch these operands from memory and store these operands in the registers before ALU can perform on them, right? Okay. And apart from this, ARM family of architectures is 32-bit architecture, while 8051 and PIC have 8-bit long data buses. Now I will talk about endianness. The endianness of a processor is how a multi-byte data will be laid out in memory, and it should not be confused with how a compound data structure will be laid out in memory. For example, endianness has nothing to do with how strings are stored in memory. It is about a single primitive data type being laid out in memory. For example, an integer. Okay, in little endian systems, the little end of the data type is stored at a lower address, while in big endian systems, the big end, meaning the more significant part of the data, is stored at lower addresses. And usually the lower address, called the base address, is what helps you identify the data type. So ARM processors are bi-endian, meaning that you can change the endianness of these processors with software instructions, and the instruction that ARM processors use to change the endianness is set end. You can look up the instruction by following this link. I provided the source code for the slides. While PIC and 8051 are little endian processors, and Intel has always been a very big fan of little endian processors. So almost all of their processors are little endian processors. It's okay to use whatever endian you want to use until you are going to communicate with other computers. So when we have two computers connected through a network, it becomes a problem if they use different endianness, because data produced by one of the processors is going to be handled in a different way by the other processor. So in that case, we have to have a standard defined, and there is one. It's called the network byte order. Any data that flows through a network has to have big endianness. So all of your data, when it leaves your network interface card, your Ethernet card, is converted into the big endian system. Okay. So ARM processors, when they receive data from the network, for example a video or any kind of data, when they receive from a network, say the internet, they don't have to do any conversions, because the network byte order is the big endian byte order, and ARM processors can be configured to use big endian systems. Okay. And the last thing that I will talk about is the pipeline. Okay. ARM processors support a very large number of pipelining stages. Okay. It's important that we have pipelining, because we don't want parts of our processor to stay idle while the other parts are performing. For example, when an instruction is being executed on the processor, we don't want our buses to be idle. We want our buses to be fetching more data, fetching more instructions. So the higher the granularity in pipelining, meaning the larger number of stages in a pipeline, the more efficient our processor will be. So ARM7 and earlier designs had 3-stage pipelines. The stages were fetch, decode, and execute, which means that the instruction being executed is 2 bytes before the instruction being fetched, 2 words before the instruction being fetched in address space. And the ARM Cortex-A8 has 13 stages in the pipeline. Okay. If we talk about pipeline in 8051 and PIC, they are very primitive in this case, meaning they only have 2 stages. When an instruction is being executed, the next instruction is being fetched. Very primitive. So with this I stop. That's all I have. Thank you for watching. Ta-da.